In this lesson, I'm going to show you how to derive Kepler's third law from Newton's law of gravitation. Now, we know that Kepler's third law describes the relationship between the orbital period and orbital radius of one planet versus another planet orbiting the same body in space. So if we sketch a diagram of, say, Earth orbiting the Sun, right there, and we have, say, another planet, a second planet, Jupiter, is also orbiting the Sun. We know that the force of gravity, there's a force of gravity that exists between the Earth and the Sun, and there's also a force of gravity that exists between the Jupiter and the Sun. And to make an object move in a circle, to orbit, that requires a centripetal force. So for the Earth versus Sun, we know that the centripetal force is provided by the gravitational force. So centripetal force would be equal to the mass of the Earth times the velocity of the Earth squared divided by the radius of the Earth-Sun, or the distance between the Earth and the Sun, RES. And that is provided by the force of gravity, or is equal to the force of gravity, which would be G mass of the Earth, mass of the Sun, divided by the distance between the Earth and the Sun, squared. So we can simplify this. We can get rid of that, and we can get rid of the mass of the Earth, and we're left with the velocity of the Earth squared is equal to universal gravitational constant times the mass of the Sun around which the Earth is orbiting, divided by RES. Now we can replace the velocity with circumference divided by the period, so the actual path, the distance that it takes to go around the Sun, divided by the period, or the amount of time it takes around the Sun. So that would be 2 pi r, and that'd be Earth, Sun, divided by TES. And square all of that, and that's equal to GMS over RES. Square the left side, we get 4 pi RES squared divided by TES squared, and that's equal to GMS over RES. Now, what I'm going to do is I'm going to rearrange this in terms of G, and we'll have G is equal to 4 pi RES cubed divided by TES times the mass of the Sun. Now, this G right here is the universal gravitational constant. It's a universal constant. It applies to all planets, all celestial bodies. And I'm going to use that fact that this right here is equal to G, which means that that relationship right here applies to every single planet. So if we look at the Earth-Sun relationship versus the Jupiter-Sun relationship, we know that, well, I'm going to restate what I just wrote, that G is equal to 4 pi RES cubed divided by the period of the Earth going around the Sun times the mass of the Sun. And I can say the same thing for Jupiter. G is equal to 4 pi R Jupiter Sun squared divided by the period. There's a square here, and there's a square here, and there's a square here. JS times the mass of the Sun. See, both Jupiter and the Earth are orbiting the Sun. So these two equations, I can set them equal to one another. So 4 pi RES cubed over TES squared times mass of the Sun is equal to 4 pi r js squared divided by t js squared times mass of the sun. And I can get rid of the 4, I can get rid of the pi, I can get rid of the mass of the sun, and I'm left with this relationship. TES squared is equal to the radius of Jupiter around the sun squared cubed. It's a cube, and that's a cube, and that's a cube, divided by TJS squared. And if I simplify this, I could just say the radius of the first planet cubed divided by the period of the first planet squared is equal to the radius of the second planet, or the comparable planet, cubed divided by its period squared. And that relationship is Newton's Kepler's third law.